Let's see if we can get this image to push. Is it done? Are you able to see my screen at all?
No, not yet.
Stop this and just try it again. Optimize. If I turn that off, that would help. Let's see. Can we see this image? Okay, I see that. That's looking good. And yeah, it looks good. Okay, so I've got the image. Okay, so that's my confirmation. Okay, so we had this question that comes from Calculus for Business. It says that an accessory company finds that the cost and revenue in dollars of producing X belts is given by this cost function and this revenue function, respectively. Determine the rate at which the accessories company's average profit per belt is changing when 180 belts have been produced and sold, right? So profit is what? Revenue minus cost. We have our revenue function, we have our cost function. They want the rate of change of the profit when we produce and sell 180. So let's go ahead and find our profit function and then take the derivative, right? Let's see. So a profit function is going to be our revenue function minus our cost function, right? So our revenue function, we have 35 x to the power of 9/10, okay? Minus the cost function. Now I'm going to go ahead and distribute my negative. So when I distribute my negative, I'm going to kind of rearrange it a bit. We get this 0.061x squared minus 36x. That's not a 36. Minus 730. Okay. I just did R of x minus C of x. Okay. It doesn't look like we really have any like terms. Okay. So now, if we want the rate at which the average profit, okay, wait a minute. So this is the profit function. If they want average profit, then we need to say P of x divided by x, right? So then, I think it's like abbreviated like that. Average profit is going to be basically that result. I'll just copy and paste. Copy and paste. It's basically going to be this divided by x. Man, this is getting nasty. Okay. Bottom times the derivative of the top minus the top times the derivative of the bottom with the bottom squared.
You said that the average profit is P of x divided by x.
Mm-hmm. I'm just thinking about how I want to take this derivative. Do I want to like rewrite it where I distribute the x into the top, which I feel like might be a little bit easier, but I'm going to attempt to do the quotient definition, all right, of derivative. So then P bar prime. So I'm going to do my low D high minus high D low over low low. So the bottom, which is this, times the derivative of the top. Okay. Man, that's a lot. I'm going to leave it like 35 times 9 over 10 times x to the power of negative 1 over 10. Right? The 9/10 comes down. You subtract 1 from the power. Let me think about this. Okay. And we need to distribute this x. So we got to be cognizant of that. I feel like this is a bit much. Bottom times the derivative of the top times the top times the derivative of the bottom. Don't want to keep going. Okay, let's keep going. I'm trying to choose which one I think is going to be more simple. Let's just keep going. So bottom times, let's keep going. So this 2, right? So we're going to say plus is basically 2 times whatever that number is. Okay, x, okay. And then minus 36. And then the derivative of a constant is 0. So we say the bottom times the derivative of the top minus the top. So we kind of need to rewrite all of that times the derivative of the bottom, which is a 1. So we have this 35 x to the 9/10 plus, kind of out of space, 0.061 x squared, 36x minus 730. Okay. Bottom is the top minus the top is the bottom, all over the bottom squared. All right. Okay. So we need to kind of like distribute, combine like terms, try to simplify as best we can. All right. So then p bar prime. Now on top, it looks like we can distribute an x across. Let me say x goes here. Looks like one. Pardon?
And do we distribute the negative to the other function?
I did that. Let me see. Oh, I see what you're saying. Okay, I see. Yeah, let's go ahead and distribute that negative. Bottom. Okay. So right here. Let me see. Okay. So that's a minus 35. This guy here, this should be a, I'm gonna just scribble it. This should be a minus, right? This should be a plus, and this should be a plus. Okay. All right, I think we're almost there. And it looks like we're also going to distribute an x times this guy. So that becomes what, 9/10? What is that? I'm still going to leave that because I just don't feel like crunching that number. It's not looking clean. 9 times 3 is what? No, that's not. 9/10. Now that's going to become what? 10 minus 1 is 9, so there's going to be x to the power of 9/10. What is that? It's 12. So 122. So I'll go ahead and multiply those. I think it's 122 like that. And it's going to be what? X squared there. Minus 36x. Okay, so we got this minus 35 x to the 9/10. We got this minus 0.061 x squared, 36x plus 730, and we still have our x squared down here. Okay. Let's see. Now, I mean, we could just plug in our number and just use this to minimize like our chances of making mistakes.
Yeah, also, Professor,
Hmm.
but where'd you get the 35 times 9 to the 10th? I mean, 9/10.
This guy right here?
No, the other one. It's 35 times 9 to the 10th.
This one?
Yes.
Let's see. Let's go back. So when we applied the quotient rule, bottom times the derivative of the top right here, when we took the derivative of this guy, the 9/10 comes down and we subtract 1, and that's where all of this came from. Okay. I think they do want us to try to simplify this. So we need to combine like terms. I guess I just need to go ahead and crunch those numbers. Let me see. That's what? 0.9. So if we say 35.9 minus 35, then that's just going to be 0.9, right? So P bar prime, I think those essentially cancel, right? And so we're left with 9/10 x to the 9/10. They said 9/10 is just like mucking stuff up, right? x squared. So I think that's like 0.61. So we're gonna say plus 0.61 x squared, okay? It looks like these two cancel each other. We got a minus and a plus. I think we've accounted for this guy already. We've accounted for this guy. So it looks like the only thing that's left is a 730. Hopefully we've caught all the mistakes, all right? Over x squared. Okay, so we got this result. Let me see, can I paste? No, I don't want that. All right, let's, well, that's not the final thing. Let's just highlight it. This is our average, this is our rate of change of our average profit. Let's compare it to what they have. Oh, they got some different stuff. Okay, so we got the x squared, right? We got 730, 0.61 x squared. Okay, so it's just that first one, 7/2. So we need to go back and figure out what did we miss there. Okay, so it's just, we got everything except for that first part. So let's see if we can find it. 9/10. Let me see. Hey Siri, what's 35 times 9 divided by 10 minus 35?
35 times 9 divided by 10 minus 35 is negative 3.5.
How do I miss that? Okay, so we just did that calculation wrong. We did it right. We just did, she said 3.5.
And that 0.61, it's supposed to be a 0.061.
Okay, yeah. I think we had it above. We just wrote the wrong thing. Yeah, that's fine. But yeah, it's, and like that's why I was pausing, because you know, I knew it was kind of like all this. This is more just about being neat and organized, because we could have distributed that x in the beginning and did a negative, but then it was going to involve all this extra factoring and trying to like get it back to the right form. That's the only reason I didn't do it. Let's see if we can get this number right. Let's see. This is just that last one that we're missing right here. We're gonna let that be for now. So let's reload and refresh. Now we got 35 times 9/10. That's a 12. 9/10 minus 35. Let's hit math as a fraction. 7/2. Okay. Yeah, we're good. That's, yeah. So we were just crunching the number wrong. So we were good. We just crunched the numbers wrong at the end. We had the right answer above, and then we wrote the wrong thing at the end. Minus 7/2 is correct. And that comes from the 35 times 9/10 minus 35. I think I was thinking of 35 plus 9/10. It was actually 9/10 of 35 minus 35. Anyway. Okay, so we confirmed their result. We got the same result that they got. Some of them, they're just like that. Like, because these things are like that, that's why I do unlimited attempts, and I try to do the minimal late penalty, or any kind of, I try to do the least amount of penalty, because some of these things are kind of nasty, right? And I'm not really trying to go hard. I'm just trying to really expose you guys to this stuff, and then just get you to work and try, and then I'm not trying to be anything tough. So, but we confirmed this rate of change of the average profit. Once we get here, then we just let x be 180. We pass it through the function, and it should spit out our result. Is that okay? Okay. So yeah. Did you have another one? We can go through some more. I'm not sure if you're talking or not because I'm hearing a weird sound, but it's not like.
Oh, wait, sorry, that's just my fridge.
Oh, okay.
Yeah, I think there's another one. I think it was in section 1.7.
So like the same kind of deal. Just click on the Axon instructor and I'll pull it up.
Yeah. Hold on.
Let me pull it up from here since I'm streaming. Yeah. Yeah, that's the nature of some of these guys. And you just got to take your time, let's write it out, space it out, get help, work together. Like, this is why I encourage you guys to work together. Try to get you guys to not stress about stuff that doesn't matter and like just try to focus on, like getting your assignments in. That's the main thing. No, that's not behaving properly. That's okay. And once you sent the next one, just let me know and I'll pull it up. I'm just resizing this for a better fit. But yeah. But I mean, but you guys' inquiries I think are legit. It's not, you got to be clear about the structure of everything. But just like when I'm like, hey guys, don't worry about that. Like the main thing is just get your stuff submitted.
Yeah, I sent it.
You sent it? Okay. Give me just a second. Like this. It's all good. I get the plight. Like I'm not even, Okay, let me pull up this next question. Yeah, we are live streaming, so let me pull it up. It's gonna be here. All right. So this comes from section 1.7, the chain rule. Cool beans. Okay, let me screenshot and copy and delete. Yeah, I really like these like updates that iOS has done. Like a lot of them are like sensible. Let me copy and delete, and then I should be able to paste it right here. No, that's not the right one. Can I just paste the image? Can I get that? Let's try it one more time. He's talking about 143 days into this thing. I'm like, who cares, man? You don't know about that. Copy like this. Copy. Can I paste it now? Yeah, nope, that's not it. Okay, let's what else can I do? There it is, that'll work. I guess my handoff is not working because usually I can copy it from my phone and then paste to my tablet. But for whatever reason. It's like they're not communicating today. I think this works as well, but I don't really want to do that. Oh, okay. Let me do this then, since this doesn't work. Oh, there it is. Finally. Let's go. We were here. Okay. All right, cool. We finally got it. Okay, so given this F and given this G, so this is F in terms of U, this is G in terms of X. Find F compose G prime of 2. Okay. Let me go back to my stream. Okay. Are you still there?
Yes.
Okay. So f of g prime, right? So f compose g prime of 2. This means we're doing what? F of g of 2, and we want to take the derivative. So this is like the chain rule, right? The derivative of the outside function times the derivative of the inside function. All right.
Mhm.
So okay. So if we take the derivative of f, we got that cube root of u. So that's like saying u to the 1/3 power. The 1/3 comes down, the u persists, and then the power now is what? Negative 2/3, right? We subtracted 1 from the power. So that's the derivative of f. That's the derivative of the outside function. Now we're going to say times. Okay, and then g is equal to u. Okay, there we go. So now times the derivative of the inside function. So the derivative of the inside function is going to be, looks like it's just 12x. Okay. But then if we want to evaluate this when x is 2, well, what about that u? So we need to basically replace that with the function g, right? Because it says u equals 5 plus 6x squared. So this is going to be 1/3 of this 5 plus 6x squared to the negative 2/3 times 12x. Okay. So then when we go to find f compose g prime of 2, basically we're going to plug 2 into that result. So it should be this 2 squared, negative 2/3, 12 times 2. Okay. You have this one pulled up right now? Let me see. Let's see if we can get a final answer here. So 4 times 6 is 24, plus 5 is going to be 29. So we have this 1/3, 29 to the negative 2/3 times 24. 24 divided by 3 is 8. So then 8 over 29 to the 2/3. Type an exact answer. See if we can submit this one and get some feedback. I feel like we can take it a little bit further. I was avoiding this, but it's okay. This one, right? This one. Go for it. Before I submit my result, I'm going to click on view an example, and I just want to see their final result, how they put their final answer. 2 parts.
Okay.
We got something like that. I think we got something along those lines, right? So you see they left it as a negative exponent. Did you already submit it? Okay.
No, not yet.
Let me see. So we got, it looks like 8 times 29 to the negative 2/3, if we match what they did. Let's turn it off. Yeah. So then we said 8 times 29 to the power of a negative 2/3. Okay, so that's correct. And again, I just used the view an example to like get a sense of the form that they wanted, right? Because we were about to, and it's not the wrong what we have. Like they probably would have accepted that as well. But we got they wanted this form. So this one was 8 times 29 to the power of negative 2/3. Did you have any questions there?
Oh, okay.
Okay. Okay. Were there others that you'd like to talk about, or?
Oh yeah. It was question number 14.
14.
Yeah. It's more like a word problem.
Just well, yeah. If it allows you to use the X-math structure, that's the simplest way to go. And so, like with these presentations, I do like that you have like thought about it ahead of time. You've considered it. I mean, it is easier when you look at it ahead of time because, like, if this was your first time seeing that and you're trying to follow my work, it can be like really hard to follow. But if you thought about it ahead of time, then those little subtle, minute details, those me receiving it. Morehouse. When you come across those subtle, minute details, then they kind of you know what you're looking for, and you'll see it, and it pops a lot better. Let's see. Can I zoom in a little bit? Okay. So it says the dosage for a certain type of chemotherapy drug depends on several parameters of the particular drug, as well as the age, weight, and sex of the patient. For female patients, the formulas giving the dosage for such drugs are this and this, where A and X depend on which drug is used. D is the dosage in milligrams, and C is called the creatine clearance. Y is the patient's age in years, and W is the patient's weight in kilometers. Compare parts A through E below. Suppose that a patient is a 51-year-old woman, and the drug has parameters A equals 4, X equals 0.7. Use the information to write the formulas for D and C that give D as a function of C and C as a function of W. All right, D is the dosage. Let's go back. Okay, right there. So it says D is the dosage is based on what A and C. So they gave us the A, where that's the age. Let me see. Where A and X depend on which drug is. Y is the patient's age in years. W, what is the A then? The dosage for a certain type of chemotherapy, there was some several parameters of drugs, age, for female patients. This, okay, and this, where A and X depend on which drug is used. Suppose that a patient, blah, blah, blah. Okay, A is 4. They gave us the A. Right? So we can write D in terms of C. Basically, we plug in the A and we'll have a function. And then C of W, what is that? The creatine? Where is it? Creatine clearance. That's with W and X. Let me see. They gave us X. And they want the creatine as a function of W. What about Y? What is a Y? Y is the patient's age in years, right? So I keep pausing because I'm having to like read through it. I keep going back and forth and filling in whatever gaps, right? So I think that we can just like type it here with like minimal notes, right? So here, let's do this. Let's do this. So again, D is the dosage in milligrams, right? So what I'm going to do, I'm going to take the function that was originally given. If I can, there we go. We have this 0.85. I'm just going to put A for now, parentheses C. I'm just typing it as I see it, 25. Okay, all right. So that was as seen. So now if we want this in terms of C, that means we're going to let C persist. I think we were given the A as 4, so let me see. So basically, we can change the A, I'm going to say times 4, and then we're going to simplify this thing. Hey, Siri, what's 4 times 0.85?
times 0.85 is 3.4.
3.4, right? So we're saying 3.4 distributing, we get this, all right? If we distribute at 3.4, we're going to get 3.4C plus, hey Siri, what's 3.4 times 25?
3.4 times 25 is 85.
85, right? So I'm gonna get rid of everything else. Is that okay what I did there? Before I get rid of this stuff?
Yeah.
Okay, we're gonna go with that. All right. So we have the dosage in terms of C. Then they want the creatine clearance in terms of W, right? So all I'm gonna do is start with the given formula, right? Same kind of deal. Let me close this out, bring it back. So I'm just gonna type the formula as I see it. I'm gonna say parentheses 140 minus Y, and then we get this fraction. Nope, that's not right. Let's do this. 140 minus Y. On top, we have W. On bottom, we have 72X. Okay. So then let's fill in the different components. Right. I'm just essentially taking my notes here. So we wanted in terms of W, we said that, so this is going to be 140 minus, now we said Y is the patient's age and she's 51. So the Y is 51. I'm just filling in the different parts. W, we want to leave this in terms of W, so the W is going to persist. And then X is given as 0.7, right? So we're going to say 72 times 0.7, okay? So then the only thing we don't know is W. If that were 60, that's like what, 89?
So 140 minus 51.
Let me see. Let me see if I can do this. Hey Siri, what's open parentheses 140 minus 51 close parentheses divided by open parentheses 72 times 0.7 close parentheses?
I found web results.
Boo.
Show them if you ask again, so you might follow.
No, I don't want to do that. Let me just pull up my calculator. I was pausing to see if I could get Siri to, because whenever she could do it, it's just so much easier. I just speak it and I get my response. That's all I'm looking for. But let me pull up. Do I have it ready to go?
There's
I'll just hang on, because it's right here. I'm gonna get it. So we're saying 140 minus 51 over 72 times 0.7. Okay. What number did you get?
Well, 140 minus 140 minus 51, I got 89.
Okay. So you can see my calculator, right? So
yeah,
I went on and incorporated the denominator to 72 times 0.7. So we were basically saying 82 divided by whatever the answer was. And the output that I got was this 1.7658. It says round to 3 decimal places. So the 8 tells me that the 5 needs to round up to 6. So then it looks like we are getting, and I'm gonna get rid of all the stuff that I don't need if I can get this to behave. Okay. So it's like we're getting 1.766 W. Before I get rid of these notes, is this okay, what we did here?
Yes.
Okay, let's get rid of this stuff and we're gonna cross our fingers. All right, because if we get it wrong, then we got to figure out what we did wrong. But notice we have the creatine clearance in terms of W, so the W remain. We have the dosage in terms of C, so that we let the C remain. Okay, we're gonna go ahead and check that result. Okay, so that was part A. So then use the formulas for part A to calculate the derivative of D with respect to C. So we have D in terms of C and C in terms of W. Okay, so the derivative of D with respect to C is just the derivative of the first part, which is just going to be, can you tell me that result there? What's the derivative of that first equation with respect to C?
3.4.
Right, it should just be 3.4, right? So we're gonna go with that. Okay. And then they want the derivative of C with respect to W. So from the second equation, can you give me the result?
It's 1.766.
Okay, that looks good. So then for part D, now when we go to take the derivative of D with respect to W, I think we could just multiply those results. That was a property that we had in class, right? It's like if you're doing the chain rule, the derivative of the outside function times the derivative of the inside function. In other words, we can just say 3.4 times 1.766. Hey, Siri, what's 3.4 times 1.766?
3.4 times 1.766 is 6.0044.
Round to 3 decimal places. So we're going to go here. Cross our fingers. Okay. So that was interesting. I like stuff like this, though. Like, it gives me hope. I mean, I'm still somewhat young. I mean, honestly, if I really wanted to go to school, and if I wanted to do that stuff, I could. I feel like I can do it, you know? I just don't really want to do it. I just want the money. So that's why I haven't done it. Because I mean, I enjoy helping people, but I just don't want to commit so much of my being to that craft, right? I don't care that much. But I do like helping people. And I do like the compensation, right? But I hate to say lazy. I'd rather say I'm efficient. I'd rather be a little bit more efficient, or I like to be efficient. Anyway, that's just random stuff. Would you like to go through any others?
Hold on.
That was interesting. Just while we wait, I'm kind of waiting on the screen here, so it's not so much fine detail things.
Oh yeah. It was question number 12. This is from section 1.8. I just sent it to you.
Let's see.
Morehouse?
Let's be a little bit easier. This one. Okay. So this, yeah. So, all right. It says on the moon, all free fall distance functions are of this form, right? Where t is in seconds and s is in meters. An object is dropped from a height of 350 meters above the moon. After 9 seconds, consider parts A through D below. How far has the object fallen? Okay, yada, yada, yada. So we have our position function. They gave us our position function as 0.81 t squared. Let's see, after 9 seconds. So it looks like for part A, we just plug 9 in. Hey Siri, what's 0.81 times 9 squared?
0.81 times 9 squared is 65.61.
65.61. Type an integer or decimal around the two decimal places is needed. Okay, we'll go with this. Okay. Then for part B, it says the object is traveling, right? So if we want the velocity is going to be.
Professor, for question A, did it say you just need to substitute 9 into the equation?
Yes, sir. Yep.
Okay.
Okay. So then for part B, if we want the velocity, that's going to be the first derivative of your position vector, right? So if we take the derivative, the 2 comes down, right? It's going to be 2 times 0.81 times t. And again, t in this case has been 9 seconds. So, hey Siri, what's 2 times 0.81 times 9?
2 times 0.81 times 9 is 14.58.
Okay, 2 decimal places. So we just basically took the first derivative and then plugged in t equals 9, and we got this result. And then, so acceleration is going to be the second derivative of your position function, which is the same as the first derivative of your velocity function, right?
We just took the derivative of the first function to get 14.58.
So for B, for the velocity function, we took the derivative of the position function, right? So this guy here, when you take the derivative, the 2 comes down. We have 2 times 0.81 times 9 in this case. And that's how we got the 14. Do I need to write it out? Okay, I'm going to let it be for now. So then with the acceleration, we could take the derivative of the velocity function to get the acceleration function. So we already have 2 times 0.81 times t. So then the acceleration should just be 2 times 0.81. And I think the t falls off. Hey Siri, what's 2 times 0.81?
2 times 0.81 is 1.62.
1.62, right? Meters per second squared. I think that's it. So explain the meaning of the second derivative of this free fall function. Yes.
I'm still trying to figure out how you got B.
What answer did we get for B?
You said you got 14.58.
Yep.
So like you just took the derivative of S of t.
Yep. So it's basically like the power rule. The 2 comes down.
Yeah, the 2 comes down.
And then you subtract 1 from the exponent. So it's 2 times 0.81 times 9.
Wait, times 9?
Mm-hmm. Because we're still considering with it being 9 seconds, and the t still persists. I feel like I should write it out. I'm just being a little bit lazy. Oh, good job. Okay.
Could you write it down?
Sure. So let's see. I really just need that function, but I'll get If we had the question ID, but I'm gonna just focus on this right here. Copy and delete. And we can paste. Oh no, did I? Hold up, I'll just paste again. Okay. What is going on? This thing is like, okay. So what we were doing here. So we were given that the position function S of t was 0.81 t squared, right? When we go to find the velocity function, that's going to be the first derivative of our position function. So then the 2 comes down, it's going to be 2 times 0.81 times t. So then I think we get 1.62 times t, and then you just let t be 9 for this one, and that's how we got the answer. And then for the acceleration function, that's going to be the second derivative of our position function, which is the same as the first derivative of our velocity function. So then that one is just going to be just, let me see. So this is meters. The units here are going to be meters per second. And this one is going to be 1.62 meters. That's not a second. Meters per second squared. So those are the units. Okay. And then so for part D, where it says explain the meaning of this, this is going to be the acceleration due to the moon in this context. So, NASA likes to lie about everything. Don't get me started on all that stuff. But for this context,
Okay.
So this should be the acceleration due to the moon. It's the gravitational constant for the moon. It's the gravitational velocity. It's the gravitational force. We're going to go with A.
And you said it's the gravitational.
Yeah. It was the gravitational constant of the moon.
Oh, okay. Thank you.
Yes.
I think that's it.
Okay. So, as you kind of continue to work through these questions, just like you did today, as you have questions, just click on the Ask My Instructor, and I'll get the email. I'll basically load it to my tablet. I'll basically recreate this, and I'll record it, live stream it to my YouTube, and then I'll reply to your email with a direct link to my video response. Right. So that's kind of how I answer homework questions usually. Or you can do live sessions like this. I do like these because we can go back and forth a little bit, Okay.
Okay.
All right. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your evening. Take care. Peace.
All right. Bye. Thank you.
Yep, my pleasure. All right.